Okay. I want to talk about logarithmic graphs. So we want to talk first about the graph of an exponential function, and then the graph of the log of the exponential function. Well, the graph of y equals b to the x, we're going to draw graphs of y equals b to the x for x equals 0.5, x equals 2, x equals 8. Starting with x equals 2, the graph of y equals 2 to the x, well, you're very familiar with that. And incidentally, all these graphs are going to go through the point 0, 1. Okay, if x is 0, b to the 0 is 1 for any value. Okay, so all graphs will go through this point. I mark that point in yellow. Then I'm going to color code these graphs so we can keep them straight. Okay, so the graph of 2 to the x, well, that's your basic squaring function. When x gets to 1, value is 2. When x is 0, the value is 1. When x is 1/2, the value is 1/2. And x equals negative 1, the value is 1/2. When x equals negative 2, the value is 1/4. And we get the familiar graph, which is going to come on up to value 4. I'm probably messing up the scale a little bit, but you should be close enough. Okay, so that's easy. And what about the graph of 8 to the x? Well, when x is 0, the graph is 1. When x is 1, the graph, the y value of the graph is 8. So we have an exponential function that pretty low here. And you can fill in the rest of the values if you want. If you understand the shapes of these graphs, you understand that this would be y equals 8 to the x. And this graph is y equals 2 to the x and 0.5 to the x. Well, 0.5 to the first power is 0.5. So 0.5 is like here. The graph is going to be this. And 0.5 is 1/2, of course. 1/2 to the second power is 1/4. And you can easily get the same values for yourself. And we see that the graph of y equals 1/2 to the x is just the reflection through the y-axis of the graph of y equals 2 to the x. I'm not sure why I wrote that as 0.5. 1/2 would have been a better way to write it, but there we have the three graphs. Okay, well, that's pretty straightforward. Now I want to do the graph of y equals log of b to the x for the same values of x. Well, the log of 2 to the x is just y equals x log of 2, which of course is log of 2, not going to write x just yet, times x. This is the graph through the origin with a slope equal to log of 2. So, when x equals 1, 2 to the x, of course, equals 2. I've marked the y scale in units of log of 2. This is 3 log of 2. This will be 2 log of 2. This is log of 2. Excuse me. Horse. Been a cool, wet April. So, again, if x is 1, and we're looking at the graph of log of 2 to the x, then y is going to be just the log of 2 to the 1 log of 2. So when x is 1, y is log of 2. I haven't labeled this. I've labeled this, and these are equal spacing here. Haven't labeled it because what I'm going to have to draw in a minute. Okay, so there we have 1 point on the graph. And of course, if x equals 0, we have the log of 1, and the log of 1 is 0. And that's because what? Any number to the 0 power is 1. Anyhow, here we have this, and we can complete the table. If x equals -1, we have 1/2, okay? And the log of 1/2, well, by rules for logs, the log of 1 over 2 is log of 1 minus log of 2. Log of 1 is 0, so negative log of 2 is -1. And we can easily confirm that the log of 2, and I'll write some of this out. Let's just, okay. We have a more or less straight line through the origin. This is the graph of y equals log of 2 to the x. Okay, well, get the right color here. Y equals log of 8 to the x is x log of 8, which we could write as log of 8 times x. Well, the log of 8 is the log of 2 to the 3rd, because 8 is 2 to the 3rd, and the log of 2 to the 3rd, by the rules for logarithms, is 3 log of 2. So we see that the graph of 8 to the x is this graph of 3 log of 2 times x. So when x equals 1, y is 3 log of 2. So if this is log of 2, here's 3 log of 2. Graph is going to go through this point. And of course, the graph of any of these functions is going to go through 0, because of course any number to the 0 is 1, and the log of 0 is 1. Log of 1 is 0. Okay, so we understand that 3 log of 2 is just some number. Turns out to be very close to 0.9. But it's just some number. It's 3 times whatever number the log of 2 is. 3 log of 2 times x is then just some constant number times x, meaning that this graph is a straight line. So I really don't have to plot any other points. I can simply draw a straight line through these 2 points. It's not as straight as I'd like it. And we have the graph of y equals log of 8 to the x. For the graph of y equals log of 0.5 to the x, or log of 1/2 to the x. I'm writing my symbols. This is the next symbol I wanted to write, the L. Okay, so we have x log of 1/2 which is, right, is x times log of 1 minus log of 2. Writing out all the steps, we're sure that we see them. Log of 1 is 0. And we see that this becomes just negative log of 2 times x. And of course, when x equals 0, log is 0, because 1/2 to 0 is 1, log of 0. Log of 1 is 0. When x is 1, this is a log of 1/2, which is the negative log of 2. Well, right here is negative log of 2. Well, that's what we get when x is 1, but I guess that's what I just calculated, and I just labeled it right over the point where I want to label this thing. So I better get rid of that as I can. So I can draw the point. Okay, well, when x equals 1, y is negative log of 2. Again, when x is 1, y is a log of 1/2 to the 1, which is a log of 1/2, which is log of 1 minus log of 2, which is 0 minus log of 2, which is negative log of 2. Multiply that by 1, here we have it. And now that I have this point and this point, missed the point. A little high, but we get the idea. Here's y equals log of 1/2. Now for homework, you're going to get to work out the details of some of these relationships, which are important and which you might not have looked at for a few weeks. Okay? The big point here is the graph of y equals b to the x is always a straight line. And you'll work out from homework why it is. And so is the graph of I'd sure like to blame this on somebody going down the hall with the cars, but first place, there's nothing to blame there. Second place, that's not why I messed up, okay? Y equals log of b to the x. In other words, these are the b to the x graphs. These are the graphs of log of b to the x. The graphs of log of b to the x are always straight. Okay, so the graph of y equals log of b to the x is always a straight line, and so is the graph of well, yeah. Can't find a damn spot in this. There we go. So is the graph of, what do you think I'm going to write? Just pretended to make that mistake, so you'd be thinking, right? Okay, well, no, that's not right. And so is the graph of y equals log of a times b to the x. And again, you get to play around with that expression using the laws of logarithms, the rules for logarithms, as part of your homework. Well, there's a little more to it, and there's some really significant current relevance. It's relevant right now, and it's probably going to be relevant for decades. And that's the coronavirus that's kind of ravaging the world right now. So we'll go on with this. Let's establish that if you graph y equals b to the x for any value of b, but we just picked these three values, doing the graph of y equals log of b to the x straightens that graph out, gives us a linear graph. And that's going to be the case for any function y equals b to the x. You can easily prove that. And then it's also going to be true for y equals log of a times b to the x.